Hello dear students, we are going to learn an easy technique for applying Kirchhoff's voltage law, KVL. At first we will take the sign convention for applying KVL and then we will solve some related numerical problems. Now we take sign conventions. Number 1, in the direction of current, IR is taken negative as it decreases potential. Means if we follow the direction of current, then all the I into R will be taken negative as they decrease the potential. Second, E is taken positive when current enters the cell from negative to positive terminal, like this diagram. Current is entering the cell from negative to positive terminal, therefore it is taken, EMF is taken positive. Next, E is taken negative if the current enters from positive to negative terminal of cell, as in this diagram. Here current is entering the cell from positive to negative terminal, therefore EMF E has been taken negative. All these EMF and I into R are written in left hand side and on the right hand side we have 0. Now with these rules we solve some numerical problems. Number 1 is find potential difference between points A and B in the following figure. This is the circuit in which we have to find the potential difference between points A and B. Solution to question 1. Here current 2 ampere is flowing from right to left, therefore voltage at point B will be positive and voltage at point A will be negative, therefore we have VB minus in the given circuit VB minus I into R2 is taken negative because it is in the direction of current. In this cell current is entering from positive to negative, therefore E2 will be taken negative. Here again I into R1 will be taken negative because it is taken in the direction of current. Current in this cell is entering from negative to positive, therefore E1 is taken positive. Now VA will be 0 because the direction of current is from right to left, therefore VB minus I into R2 minus I into R1, current is entering the cell, this cell, current is entering this cell from positive to negative, therefore E2 has been taken negative. Again I into R1 is in the direction of current, taken negative. Current is entering in this cell from negative to positive terminal, therefore E1 is taken positive and point A will be at minus, will be at negative potential minus VA, therefore VB minus VA will be equal to E2 minus E1 plus I R1 plus R2. E2 is 15 volt E1 is 10 volt plus I is 2, R1 is 1 and R1 is 2 and R2 is 3 ohm. So we have 15 minus 10 plus 5 into 2 is 10. It gives 15 volt. So next question number 2. The question is, in the following circuit find current I3. This is the circuit in which we have to find the current I3 flowing in this resistance. Now solution to question 2. At this point, at point C, Kirchhoff's current law gives I1 plus I2 is equal to I3. I1 is 20 minus Vc upon 2 ohm. 20 minus Vc upon 2 ohm plus I2 is 5 minus Vc upon 4 ohm. 5 minus Vc upon 4 ohm is equal to I3 is Vc minus 0. Vc minus 0 upon 2 ohm means B of A minus B of C upon this resistance is I1. B of B minus B of C upon this resistance is I2. Similarly, B of C minus 0 volt upon 2 ohm is I3. Now this gives BC is equal to multiplying both sides by 2 we get 2, here 2, 2, multiplying both sides we get 2. So therefore 20 minus Vc plus 5 by 2 minus Vc by 2 is equal to Vc. That is Vc plus Vc plus Vc by 2 is equal to 20 plus 5 by 2 or 5 by 2 Bc. 5 by 2 Bc is equal to 45 by 2. This gives Bc as 9 volt. This gives VC as 9 volt. Therefore, I3 will be equal to VC minus 0 upon 2, which is 9 upon 2 is equal to 4.5 ampere. Next question number 3. The question is, in the following circuit, find potential difference between points A and B. This is the circuit in which we have to find the potential difference between points A and B. Here current I is flowing from left to right. Therefore, VA will be at higher potential and VB will be at lower potential. Now, using sign conventions for KVL, we have in the given circuit VA, suppose this is IA, the I into 2 ohm will be negative because it is in the direction of current. I into 2, again current is entering the cell from positive to negative, therefore E will be taken negative. Again I into 1 ohm will be taken negative, it is in the direction of current, minus B will be 0. Therefore, VA minus VB will be equal to E plus I into 2 plus I into 1 means I taken common 2 plus 1. So, we get 3 plus 2 into 3 means 9 volt. Now, question number 4. The question is, in the given circuit, in the following circuit, find the current. Here suppose this is R1, this is E1, this is E2, this is R2. Solution to question 4. Because E2 is greater than E1, therefore current will flow from right to left. Now, current will flow from right to left like this. So, here in this cell, current is flowing from negative to positive, therefore E2 will be positive. Here positive to negative, E1 will be negative, minus I into R1 will be negative, minus I into, suppose this is R3, I into R3 will be negative, minus I into R2 will be negative. So, right hand side is 0. Here E2, in this cell current is flowing from negative to positive, therefore E2 has been taken positive. In this cell current is flowing from positive to negative, therefore E1 is taken negative. I into R1, I into R2, I into R3 have been taken negative. Therefore, E2 minus E1 will be equal to I R1 plus R2 plus R3. E2 is 8 minus 4 will be equal to I taken common 2 plus 1 plus 9. 2 plus 1 plus 9 means 12 I. Therefore, I will be equal to 4 upon 12, that is 1 by 3 ampere.